Now, one of the concepts that is important in probability analysis is called sample space and counting how many outcomes are there in the sample space. Suppose if we have an experiment, okay, quote unquote experiment, so that is a die with 6 faces, and you want to roll the die and observe. Okay, what are the possible outcomes? So the sample space has 6 outcomes: 1, 2, 3, 4, 5, 6. Okay, so it's a simple case. You don't have to have any counting rules. But suppose if we say we have 5 dice, each with 6 faces, and we throw the 5 dice and then observe the results of those 5. Okay. Now, how many possible outcomes are there? Okay. Now, if you don't have a systematic way of counting, it's going to be extremely difficult for you to figure that one out. Okay. And same case in the case of a deck of cards, 52 cards. Suppose if you say that I want to take 1 card at random out of those 52 cards, and how many possibilities are there? Well, it's very easy. It's those 52, 13 of each suit. Okay. But suppose if we say that I'm going to deal out 4 cards out of that 52 at random. So how many possibilities are there for that combination of 4? And now this becomes more difficult to figure out. So we need some systematic way of counting how many possibilities are there. Okay, let's start with some simple rules. Okay, so here, very simple rule, counting rule is k to the power of n. So that is, if you have k different mutually exclusive and collectively exhaustive events, and there are n trials. So for example, if you have a die, you have 6 faces. So when you throw the die, only one of those 6 outcomes can happen, and they collectively describe the entire possibilities, and they are mutually exclusive. And suppose if I say I'm going to throw the die 6 times or 5 times, which is the same as saying I'm going to have 5 dice and throw. So each one has 6 possibilities. So if you use this rule, k to the power of n, that will give us totally how many possibilities are there for those 5 dice. So here there are, suppose if we want to throw 3 times, so if you roll a fair die 3 times, okay, k is 6, each die, each trial has 6 possibilities. So 6 to the power of 3 will give you the total number of possibilities, 216. Because that's counting rule number 1, k to the power of n, k being the number of possibilities in one trial and how many times you try. N is that. Okay. Now counting rule number 2 is, suppose if you have different number of possibilities in each trial. So first trial there is k1 possibilities, second trial k sub 2 possibilities, and so on. Then if you simply multiply all those different possibilities, then you get the total outcomes. So you want to go to a park, eat at a restaurant, and see a movie, evening outing. And there are 3 different parks, there are 4 different restaurants, and 6 different movies to choose from. Then you have 3 times 4 times 6, that gives us the total number of unique possibilities. Counting rule number 3. So how many ways can you arrange n items? Suppose if you have a race and there are 6 participants in the race. So how many outcomes are possible in terms of the first person, second, 1, 2, 3, 4, 5, 6, right? So how many possible ways in which the race can end up with? Okay, and that's simply factorial, n factorial. Okay, n times n minus 1 times so on until 1. So if there are 5, so you have 5 books to put on a bookshelf. How many different ways in which you can arrange the books? Okay, the same as saying, if you have 5 people running a race, how many possible outcomes are there? So there are 120 possible outcomes. So that's counting rule number 3. Then permutation is, so if you have 5 people running a race and you want all the possible outcomes, then it is 5 factorial, right? But suppose if you're interested in only in the first 3, your 5 people are running, how many ways in which you can have 1, 2, and 3? So gold medalist, silver, and bronze. Okay, and let's assume that there are 10 people. 10 people are running. how many possibilities are there for medals. Okay, and that is permutation, where you have n is the total number of people starting with, x is the number of objects that you're interested in. So 10p3 would be the number of possibilities for medals. So here we have 5 books and you want to put 3 on shelf. So 5 combination 3 will give 60 different possibilities. Counting rule number 5 is combination. Here in combination, you're not interested in the ordering. Okay, same race example. Let's take race. So 10 people running, and in the previous case, you're interested in who is the gold medalist, who is the silver medalist, who is a bronze medalist, and how many possibilities are there. Then you go 10p3. Okay. Suppose if you're not interested in the gold, silver, or bronze, you just want 3 medalists. Don't care which medal. Then it is a combination. A better example would be, suppose if you have 10 people to choose from and you want to send 3 of them for some training somewhere from your department. Okay, and you don't care, there are no restrictions, as you just want to pick at random 3 people out of 10. So here it doesn't matter whether it's a first rank or second rank or third rank, you're only interested in the group and not the ordering within the group. Okay? Think about it. So if you're interested in the ordering within the group, like gold, silver, and bronze, there is an ordering within the group. Whereas here you're not ordering within the group, it's just the group. Then you have n combination x, and the formula is this for that. So the last 2 rules can be confusing. You have to pay attention to that. In permutation, you're interested in the ordering within the group. Okay? Whereas in combination, you don't care about the ordering, you just look at the membership in the group. So that's counting rule number 5. Let's look at some worked out examples for counting rules. So let's start with problem number 4.40. So if a coin is tossed 7 times, how many different outcomes are possible? So we're assuming that a coin, when you toss, it will land either as head or tail. So only 2 possible outcomes. So k is 2, and you're repeating it 7 times. K is 2, you're repeating it 7 times. So k to the power of n. So that will give us the total number of possibilities. Now what about B? Okay, B is, if a die is tossed 7 times, how many different outcomes are there, and discuss the difference in your answer between A and B. Now here, when you're talking about a die, there are 6 possible outcomes in a single trial. So k is 6, this is 7, so k to the power of number of trials, that gives us the total number of possibilities. Okay, obviously the difference is because each trial in B results in 6 possibilities, whereas in A it resulted in only 2 possibilities. Okay. Now let's look at problem number 42. Here, if you like to build your own burger at a fast food restaurant, there are 5 different breads, 7 cheeses, 4 cold toppings, and 5 sauces in the menu. And how many different unique combination of the burger can you make? So here are the choices in each category. So k sub 1, k sub 2, k sub 3, k sub 4. So the number of possibilities is the product of all of them. So we can use the Excel function product and the range, so that will multiply all those different numbers and you get the total number of choices. Okay, next is problem number 44. So here, in a Major League Baseball, there are 5 teams in Eastern Division: Atlanta, Florida, New York, Philadelphia, and Washington. How many different orders of finish or there for these 5 teams. Assume no ties. Okay. So all of the 5 teams you want to order them. So you're not choosing just a few from that 5. So when you're not making a choice of a subset, then it is simply n factorial. So which is there are 4 teams. There are 5 teams. So it's just simply 5 factorial, and there is a function in Excel called fact, and factorial gives fact gives us the factorial of 5. Okay. Now problem number 48. 4 members of a group of 10 are to be selected for a team. So how many ways there are there to select these 4 members? So you want to select 4 out of 10. It doesn't matter. These 4 people, there is no position there. It's just 4 people. The group membership, that's all. So n is 10, C is 4. So the number of groupings that we want is 10 combination 4. Okay. So that is equal to 10 combination 4. Combination 4. So we have a function for that combination, okay, n, and the number to be chosen. So that's it. Or if you want to use the formula, we can do that too. So we can do factorial n factorial. Okay, so that's the numerator divided by, we have factorial of C times factorial of n minus C. That will give you the same answer, obviously. But suppose, an extension to this problem, suppose if these four people in the team are to be assigned to 4 different positions, okay, in the team. So then the ordering becomes important in that case. So if that is so, then the number of possibilities then becomes 10 P4. Okay. So for that we have what is called permutation. Okay. 10, 4 will give you that possibility. Okay. And again, we can compute that using factorial of n divided by factorial of n minus C.